Yes, it's 1:15. Well, hello, everyone. So, what do you say we party on Windows Phone for a little while, huh? Lots of Windows Phone lovers here, I suspect, as I am. I love writing Windows Phone apps. In fact, I love writing all kinds of apps, but I especially love writing Windows Phone apps. My name is Jeff Procyse. You can see how the name is spelled right up there, and also see my email address should you need to contact me with questions or follow-ups or anything like that. And just to make sure you're in the right place, the title of this session is Windows Phone 8 for Windows Phone 7 developers. And the objective of this session is to take folks who have already built apps for Windows Phone 7 and are pretty familiar with that API, and to introduce you to what's new in Windows Phone 8. Excuse me. So that you can get a fast start on building apps that leverage the new features. So just to emphasize, I'll be covering the delta between 7 and 8 here. Nonetheless, if I talk about something in Windows Phone 7 that's not familiar with you, just throw up a hand. I'd be glad to answer any questions that you have. But we're going to try in the next 75 minutes to hit all the new features of Windows Phone 8 that really matter from the perspective of a Windows Phone 7 developer. Now, first thing you should know, if you don't know already, is that Windows Phone 8 is API compatible with Windows Phone 7. That means that to first order, if you want your Windows Phone 7 app to run on Windows Phone 8, it should just work. Now, you have a couple of options here, and I'll say more about these in just a moment. You can recompile that app as a Windows Phone 8 app if you want, or you can simply allow it to run as a Windows Phone 7 app. The APIs have been built to be backwards compatible. You may wonder, so if the APIs are backwards compatible, but wait a minute, wasn't I supposed to get a whole bunch of new APIs in Windows Phone 8 from Windows Phone 7, or rather from Windows 8? Well, you do, but all the old APIs are still there. What has really changed about Windows Phone 8, besides the new APIs that they've introduced, is that they've swapped out the kernel. In Windows Phone 7, the kernel was based on the Windows Compact framework, which was in turn based on Windows CE. That is no longer the case. They did take the Windows 8 kernel, the same one that runs on desktop machines, and they have that running on Windows Phone 8 now. Of course, for us, working with APIs that the operating system exposes, we'll probably never notice that. There are some tiny, tiny ways that the new kernel could affect you. For example, the garbage collector works differently now because it's a different garbage collector that's running. But unless you're doing something that you shouldn't have been doing to begin with in Windows Phone 7, like relying on the order in which objects are finalized, you as a developer should never see these changes in the kernel. What's really important to us, and what I'm going to focus on, are all the new APIs, all the new things that you can do in a Windows Phone 8 app, above and beyond what you could do in a Windows Phone 7 app. And one of the big things that you may or may not already know is that you can now write phone apps in unmanaged code. Back in the Windows Phone 7 days, we had one option and one option only, that was to write in managed code like C#. You can still do that in Windows Phone 8, obviously, but you can also write unmanaged C++ code. If you're building a game that needs performance above all else, that might be a route that you wish to take. I think that most Windows Phone 8 developers, however, will still choose to go the managed route. There was some speculation before Windows Phone 8 shipped that you might be able to write HTML and JavaScript apps for Windows Phone 8. That was just speculation. It's not the case. That may happen somewhere down the road. In fact, I wouldn't be surprised if it does. But at least with Windows Phone 8, you don't have the option of writing in JavaScript and C#. Now, let me kind of give you the lay of the land here by describing what Windows Phone 8 looks like from an API standpoint. When Windows Phone 7 came out, what they had essentially done is taken a build of the Silverlight runtime and adapted it to the Windows Phone. And they called that adapted Silverlight runtime .NET for Windows Phone. Well, .NET for Windows Phone is still there. This is the big reason your old Windows Phone 7 apps can still run, and you can still use the old Windows Phone 7 APIs. Now, they have enhanced it some. They've added a whole bunch of new types and a bunch of new namespaces, allowing us to do things that we couldn't do in Windows Phone 7, and obviously I'll be talking about those in this talk. But they also did something else kind of interesting. If you write Windows Store apps for Windows 8, you may be aware that you use a combination of the .NET framework, the .NET profile for Windows 8, and a new runtime called WinRT, which is short for the Windows runtime. They adapted portions of the Windows runtime from Windows 8 to Windows Phone 8, and they give it the name Windows Phone Runtime, or WPR. Now, the Windows Phone Runtime provides part of the APIs that you need. .NET for Windows Phone provides the other part of the APIs that you need. If you look at the Windows Phone Runtime itself in more detail to see what they've done, they didn't attempt to port all of WinRT from Windows 8 over to the phone. There are about 11,000 members, types, and other things in WinRT for Windows 8. They adapted, excuse me, about 2,800 of those. So roughly 1/4 of the WinRT APIs that Windows Store developers are using are available on Windows Phone 8 as well. In addition, while they were porting part of WinRT over to Windows Phone 8, they added some additional types and some additional type members, adding capabilities to WinRT that don't even exist on Windows 8. We'll be looking at those APIs as well, but what I want you to realize right now is that when I refer to the Windows Phone runtime, I'm referring to the part of the WinRT, the Windows runtime, that was ported over from Windows 8 and had some stuff added onto it that is phone specific. Together, the Windows Phone runtime and the .NET for Windows Phone runtime make up the bulk of the APIs that we rely on from a Windows Phone 8 app. Now, I mentioned that you do now have the option of using native code to write Windows Phone apps as well. Something that's new in Windows Phone 8 is you can use Direct3D and other items that come from unmanaged code land, like Xaudio 2, which is part of the direct audio from your applications. I'm not going to talk a whole lot about that because I don't write Windows Phone 8 apps in unmanaged code, but I want you to be aware that it's there. And again, to be aware that if you are building 3D games or something where you value performance above all else, you do have some options now that you didn't have in Windows Phone 7. Now, before we start talking about new APIs, let's talk just a little bit about backwards compatibility. I was pleasantly surprised when I first got my hands on pre-release builds of Windows Phone 8 to find that my Windows Phone 7 apps would simply run on Windows Phone 8 without even having to be recompiled. Obviously, that's because they still have the old APIs there. It's interesting, though. There are a lot of things that are different about Windows Phone 8 and Windows Phone 7. And when you run an unrecompiled Windows Phone 7 app on Windows Phone 8, they actually insert a layer between the runtime, between the operating system itself and your app, that we call the Quirks mode layer. The objective of Quirks mode is to take the things that are different about 7 and 8 in terms of API behaviors and make them work as if you were running on Windows Phone 7. If you recompile that Windows Phone 7 app, however, so that it is now a Windows Phone 8 app, it's a Windows Phone 8 binary, then it will run against the Windows Phone 8 operating system without that Quirks mode runtime. And obviously, if you create a new Windows Phone 8 app from scratch, compile it as a Windows Phone 8 app, it will run without the Quirks mode runtime as well. Now, that Quirks mode runtime is designed, obviously, to make sure that Windows Phone 7 apps just work on Windows Phone 8. But it's not perfect, and Microsoft has actually been very diligent in documenting all of the breaking changes, the changes that were not quirked, for example. There's a URL in the final bullet point on this slide that you can go to for a list of literally everything that might break code from that you're bringing forward from WP7 and that is not quirked. It is a fairly lengthy list, but if you take time to examine the list, you'll see that for the most part, it's pretty minor stuff that for the most part you're not likely to get into. For example, the fact that the garbage collector does work differently now. The fact that local database works a little bit differently, and as I indicated here, no longer supports read-only connection strings except in certain locations. There's a very good chance if you've written WP7 apps that none of these breaking changes will affect you. But if you do test you, if you're bringing a WP7 app forward, you test it on Windows Phone 8, and you see that certain things are not working, hopefully you have unit tests that you can use to test against, then this document at the bottom is the one you want to refer to find out what changes you need to make. Now, that's the last thing I'm going to say about compatibility, because from here on out, I want to talk about the features that you can include in a Windows Phone 7 or Windows Phone 8 app that you could not include in a 7 app, and also talk about things like new screen resolutions, things that you now have to think about in Windows Phone 8 that you didn't have to think about before. So one of the nice things about Windows Phone 7 was every Windows Phone 7 device had a screen with exactly the same resolution, 800 by 480. Sometimes that made us a bit lazy as developers because we would hard code for that screen resolution. We kind of knew when we did that in the back of our minds it might bite us someday, right? Because we knew that there would be future devices with higher resolution screens. The team that built this, however, has done something really, really clever. So even though, yes, there are several new screen resolutions that are supported, to a large extent, this is transparent to you. Have you noticed, by the way, if you just take one of your WP7 apps without recompiling it or anything and you run it on Windows Phone 8, it still looks good on the screen? Even though you may have designed it for an 800 by 480 screen, your app still fills the screen and actually looks very nice, probably doesn't look pixelated or anything like that. Well, here's why that is and why you need to know about these new screen resolutions. First off, the old 480 by 800 screen resolution is still supported, but most of the newer devices like this Lumia 920 that I have here and I'm going to use in my demos has a higher resolution screen. But the Windows Phone team adopted something, a little trick from the books of the Windows 8 team. They do something called resolution scaling. It's kind of like those much talked about Retina displays that Apple has put on the latest iPads. You may have a very high physical resolution, but your effective resolution is much smaller. Now, if you look at these three screen resolutions right here, you'll notice I've put some numbers underneath them, like 15.9, 1.0, 480 by 800. Take a look at the screen in the middle, the so-called WXGA resolution. Although its physical resolution is quite a lot higher than the old 480 by 800 screens, everything shown on that screen is scaled by a factor of 1.6. So in your mind as a developer, you still assume that you're working on a 480 by 800 screen, and everything gets scaled up. So if you've put an image on there that measures exactly 480 by 800, for example, it will be scaled up by a factor of 1.6 in both horizontal and vertical directions so that it still fills the screen on a WXGA device. Even for the even higher res devices, the 720p's, they're using a resolution scale to scale everything up. And although the physical resolution is quite a lot higher, you're working with an almost identical virtual resolution. The only difference is it's virtually a little bit longer, so you have a slightly different aspect ratio to deal with. So here's what this means to you as a developer. Number one, hopefully in your WP7 apps, you didn't assume anything about the screen resolution. If you were to hard-code a grid control to 480 by 800, for example, you might find that it doesn't use all of the screen in a WP8 app. But if you didn't dimension that control, if you allowed your XAML scenes to flow to fill it up and to flow with available real estate, then you should be just fine. Even the imagery and the tiles that you provided in a WP7 app generally look just fine on a larger screen because they get scaled up automatically. That does open the possibility, however, of some pixelation. And although it's a little bit hard to see, when you run WP7 apps on WP8, because of the resolution scaling, there is some pixelation taking place. Which is why, if you're designing for WP8, what we want you to do is design as if it were a 480 by 800 screen, but to provide higher resolution images. I'm going to show you how to do that in just a moment. One other thing to think about too is if you're using a splash screen in your app, you'll probably want to know, okay, what resolution image should I use to fill the screen? Well, what you want to do is use a 768 by 1280 splash screen. That fits the newer, larger resolution or higher resolution devices very well and scales down nicely to 800 by 480. But I also want to mention, you may notice that there's an asterisk following that final top-level bullet point after the word splash screen. Have you noticed that when you create a new WP8 project, by default, Visual Studio doesn't include a splash screen image in it? Have you noticed that, and did you wonder why did they eliminate the splash screen? It's because they think that splash screens will be used less now because they'll be seen a lot less. I didn't build any slides on this, but I wanted to briefly mention a new strategy called Compile in the Cloud, which you may have heard referred to with Windows Phone 8. Basically, it used to be in Windows Phone 7 that when your C# code got compiled, it got compiled into IL as normal. Then when a ZAP file got downloaded to your phone containing that IL, the IL was just-in-time compiled or JITted for the native processor. And that's one of the reasons sometimes splash screens were there for a few seconds, because it took time to do that initial JITting. They did something kind of clever in Windows Phone 8. They defined something new called MIDL, MDIL, which stands for Machine Dependent Intermediate Language. So basically now, when you upload that WP8 app to the store, what's actually getting downloaded to a user's phone who chooses to download and use your app is no longer just the old IL that you're familiar with. It's the newer IL, MDIL, which JITs a whole lot faster. The whole idea here was to allow these apps to start up a lot faster to improve the user experience. And you may find now that your app startup is so fast you no longer need a splash screen because it would be displayed for so little time the user would hardly see it anyway. That's the big reason that they chose not even to include a splash screen by default in a Windows Phone 8 project in Visual Studio. If you want to provide one anyway, if for whatever reason you find that yours is taking a few seconds to start up, then you want to use a resolution of 760 by 1280. Now, along with new screen resolutions, which has largely been abstracted away again, you just pretend that it's a 480 by 800 screen. Don't hard code anything, but let the system scale everything up as needed. You should also know that we have 3 different tile sizes in Windows Phone 8. If you've played with it, you've noticed that now the user can switch a tile between a square tile, a wide tile, and a small tile. There's a little bit that you need to do to think about as you are designing a WP8 app in that regard. Number one, if you want to support all 3 of those tile sizes, then you need to provide 3 different images, 3 different icons, if you will, for your app. The resolutions may look a little bit odd. The tiny icons you see in a Windows Phone screen are bitmaps whose physical dimensions are 159 pixels square. The square tiles you see measure 336 pixels square, and the wide tiles measure 691 by 336. Now you may think, but wait a minute, Jeff, you just said design everything as if it were a 480 by 800 screen. That 691 pixel wide tile is going to take up most of the screen. Well, that's not quite what happens, because they're scaling these things down too, using resolution scaling so that they fit the screen nicely. Your job is simply to provide the tile imagery in those sizes, and then to let the OS size them appropriately on the screen so that they take up the proportional amount of space that they're supposed to take up. One other thing to know with regard to tiles, too, is that they've introduced 3 new tile templates. Now, in Windows Phone 7, tiles didn't give you nearly as many options as they do in Windows 8. In Windows 8, for example, we can push out tile updates. We can have Windows 8 queue those updates and automatically roll the tile between the different pieces of content that we give it in those queued updates. They didn't adopt this exact model in Windows Phone 8, but they did define 3 different tile types that we can use in our apps. Now, if you want to use one of these tile types for your app's primary tile, the one that's created when the app is installed, then you specify which of these 3 tile types you want in the manifest. You still have the option of creating secondary tiles in a Windows Phone 8 app, just like you did in version 7. And since you're programmatically creating those, you can also choose at creation time which of these three tile templates to use. Now, the 3 tile templates that they give you now are the flip tile, the cyclic tile, and the iconic tile. The flip tile is one that basically lets you specify content back and front. Then the operating system periodically flips it to show to flip between the front content and the back content. They gave us some of this capability in Windows Phone 7.1, but they've made it a little bit richer here. 7.1 did not support the other two template types. Cyclic allows you to assign up to 9 images to the tile so that the OS can cycle between them periodically every few seconds. And Iconic is a new tile type that lets you show more information on a tile. In fact, Iconic, I think, is going to be so popular that I decided to pull this out and drill down into it in just a little bit more detail. This is what a new Iconic tile looks like. Again, you couldn't do this in Windows Phone 7. This shows it in the 3 different sizes. You don't have to support all of those. The wide tile is optional. But if you do choose to support all 3 sizes, this shows the element that makes up the tile. The whole idea behind an Iconic tile is that, number one, you can provide an image with a transparent background, which the OS will show on the tile, and the tile has a badge, a number that can be anywhere from 1 to 99, that you can update programmatically or from a web service. Yeah? That's a good question. Are these provided in Windows 7.8? I think so, but I'm not going to swear to that. To be honest with you, Windows 7.8 doesn't interest me that much, so I haven't spent a lot of time on it. I think, don't quote me on this, and if it's important to you, double check me, but I believe that they do support the Iconic tile in 7.8, I think. Now, along with these new tiles, they give us some new classes, some new APIs. In fact, there are 3 new tile-related classes called Iconic Tile Data, Flip Tile Data, and Cyclic Tile Data. These are the classes that we use if we want to programmatically update content on our application's tile or on its secondary tiles if you've elected to create those. I provided one example here. Let's suppose that I've chosen for my app's primary tile an Iconic tile, one like you saw in the previous slide. And now at runtime, I want to update it. Maybe it's a mail app or something. I've seen a new mail message arrive, and I want to update that count on the tile to show the user how many messages are now waiting. Well, I simply do this. I new up an Iconic Tile Data object, use its properties, and there are more than just the one shown here, but here I use some of its properties to specify what I now want to appear on that tile, and then I call update on the tile. This is very different than the Windows 8 tile API if you've played with that some, but in terms of capabilities, it gives you the ability to do, with a slightly different API, a lot of the things that we do in Windows 8. In fact, it even goes beyond Windows 8 in some respects, because while Windows 8 supports queued tile updates and a few other things, Windows 8 does not have built-in support for these Iconic tiles that we can use on the phone. So let me show you a quick example here of an Iconic tile at work. What I'm going to do, I've got my phone wired up here. I'm going to pop out of here and try to get my phone screen up on the big screen for you. So there it is. Let's unlock it. Let's unlock it. There we go. And I want to swipe over here to my apps. And by the way, if you'd like a copy of these samples, I'll provide a URL from which you can download them. And I'm going to go to something called, I thought I called it Iconic Tile Demo. Well, I do know that I have an icon for it out here, so whatever I decided to call it. And where did it go? And it has mysteriously disappeared. That's okay. What we'll do is go into Visual Studio and just push it out to my phone. How about that? So, I'm going to open up a sample project here. One of several that I brought along with me. And we'll push it out to the phone and see an Iconic tile at work. Whoops, not that one. See, I chose Windows 8 instead of Windows Phone 8. There's Windows Phone 8, and there we are, Iconic Tile Demo. So, fire it up in Visual Studio. I'll make sure it's pointed to the device rather than the emulator. Make sure my screen is unlocked, which it is. And now let's push it out. And I'll go back here so that you can see what I'm doing on the phone. Hopefully we'll see that application start up there in just a moment. Okay? And you can see the app itself doesn't do a whole lot, but now that it's out there running and installed, let me close it off in the debugger here. Are we back to the Visual Studio? We are. And then let's go back to my phone here. Swipe over, find iconic tile demo. And I'm going to create a big tile for it out on the start screen. There it is, iconic tile demo. And you can see that it is an iconic tile. I'm using a pretty plain icon, but I'm taking advantage of the fact that we can now put a badge, a number from 1 to 99 on the tile. And all it's doing is showing you the launch count. It's showing you the number of times it's been executed. So if I start this thing again, clearly it just got launched again, and then I go back out to the start screen, we should see that roll up to a number 2. Well, let's try that again. We should see that roll up to a number 2. Scroll back up there. Ah, and there we are. It must have been asleep the first time. Let's try it one more time. Bing, right here. Go back there, and I would expect to see a number 3. So yeah, all I'm doing is each time the app is launched, I'm writing a record of how many times it's been launched out to isolated storage. And then when it starts up, I new up one of those iconic tile data objects and update the count shown on the face of the tile. Now, do I support wide tiles here? Let's find out. I'll press and hold that. Make sure you can still see what I'm seeing. First, we'll take it small, then we'll take it wide, and there we are. In fact, I am supporting that. With a wide tile, you have the option not only of showing an icon and a count or badge, you can also show a few lines of text, and in those lines of text, I'm describing what this application does, kind of built-in documentation there, if you will. Now, I've got other examples involving the new tile types I'm going to show you, but to summarize what's new in tiles, we have 3 new tile templates. The new iconic tile, which does exactly what you saw. The new flip tile, which lets you flip between front and back content. And the new cyclic tile, which allows you to rotate between images, between up to 9 images on that tile. Yeah? Can I have different background images? Yeah, you can change the background image. And on a flip tile, which has both the front and back, you can set an individual background image for the front and the back. Absolutely. Yes. And you can, by the way, on a cyclic tile, you can programmatically change the images that you've queued up to cycle between. So yes, you always have that option. Okay. So that is fairly interesting, I think. It's at least something you should know about, but it's really just the tip of the iceberg in terms of the new stuff that we have to play with in Windows Phone 8. So let's talk about controls. One of the things that I like about Windows Phone in general is that it gives me a very rich set of XAML-based controls. You know, things like panorama and pivot. Controls that not only pack in a lot of functionality, but have really come to identify a Windows Phone app as a Windows Phone app. Well, you'll be glad to know that all those controls that you've worked with in the past are still there, and some interesting things have happened to them as well. For example, the pivot control and the panorama control are used so much in Windows Phone apps, they've moved them out of the runtime and into ROM so that they will execute as fast as they possibly can. The web browser control in Windows Phone 8, instead of being based on IE9 like the one in Windows Phone 7, is now based on IE10. Among other things, that means if you're using HTML5 to build cross-platform mobile apps, you have a much richer HTML5 feature set to work with in Windows Phone 8 than you do in Windows Phone 7. Another thing that's worth noting, some of you may be aware that in Windows Phone 7, if you used a progress bar control, it was really bad for the battery because of the way it was designed, the way it was architected. You may recall that in Windows Phone 7.1, they gave us a new progress control that lived inside the system tray, outside of managed code land, just to address that issue, that battery drain issue. It was only when the control was in the indeterminate state, by the way, that it was so bad for the battery, but it was bad indeed. You'll be glad to know that they have fixed the XAML progress bar control in Windows Phone 8, so that even if it is in indeterminate mode and you have those 5 little dots chasing each other across the screen, you're not draining the user's battery power at 10 times the normal rate. So that's been fixed. You can use indeterminate progress bar controls without worrying about it. So they also added some new controls for us to play with. There's a new map control. Now, of course, there was a map control in Windows Phone 7 as well, but you may be aware that Microsoft struck a deal with Nokia. The new map control is based on Nokia maps and has some interesting capabilities that the old maps control did not. The old Bing Maps control is still there, by the way, for backwards compatibility, but if you're building a Windows Phone 8 app, you would prefer to use the newer map controls instead. They did something else interesting too. Some of you may have used the long list selector control from the phone toolkit. They basically moved that over to the runtime itself because it's something that developers found so useful. So I wanted to show you a bit about this new control, long list selector, in case you've never used this before. Syntactically, it's a little bit different than it used to be back when it was just part of the toolkit, but once you get your head around it, it actually works quite well. The idea behind the long list selector is just like in your phone's contacts. When you're browsing your phone's contacts, if you have 200 or 300 or 400 contacts and you want to find someone way down the list, you don't want the user to have to scroll and scroll and scroll. So they generally tap the little block that contains the first name of the first letter of a last name. That shows a bunch of alpha blocks, allowing you to quickly get to the Y's or the Z's, for example. That's what a long list selector is. It's ideal when you're presenting a list of items to a user. The list could be very long, and you want to categorize those by alphabetizing them or something else so that the user can easily navigate from one item to another in that list. Windows Phone 8, again, that's part of the runtime. You no longer need a separate toolkit to do that. And the first step in using a long list selector control is to declare one, as I've done here. It has a few properties which you'll probably find useful. If you do want the user to be able to jump out of the detail view and see the view from orbit so they can easily navigate to another part of the list, then you want to set the is grouping enabled property to true. Hide empty groups is useful also, because if you are using this in, say, a list of contacts and you don't have anyone in your list whose last name begins with a Z, well, why even bother showing the user the option of jumping to the Z's in the list? This control does support templates, not surprisingly. There's an item template that lets you describe in XAML how the items in the list should be rendered. And there's a separate template you can provide called a group header template that specifies how you want the group headers to be rendered. If you haven't seen these before and aren't quite picturing in your mind what a group header is, it's okay. I'm going to show you an example right here in just a moment on my phone. Now, in terms of binding a long list selector, this is the part that's probably the hardest to figure out from the documentation. So I wanted to include some information in the slides as well as some sample code that you can download. What you want to create is a two-level list of items. So in this case, assuming we're going to use the long list selector with the list of contacts, I create a list of groups of persons. The person class is just a very simple C# type. I built a property into it named name with the name of that person. The group property is designed to contain a group of people. And as you'll see on the next slide, I built a special property into it named key, which specifies the key for that group and allows the long list selector to work. In fact, this is what those two classes look like. You can see there's nothing remarkable at all about the person class, nothing really remarkable about the group class, except the fact that it has a group property which is designed to wrap a list or IEnumerable of other items, in this case people. But you'll notice that property, the public string property named key, that is what's really key to allowing it to work with a long list selector. So with that, let me pop back over to my device and let me show you an example of a long list selector at work. So right here, let's get back to camera view and wake up my phone. and go over to the long list selector. In fact, this is a jump list that you're looking at right here in long list selector demo. What I'm doing here is programmatically enumerating all of the contacts on my phone. So you're seeing a real list of my contacts, including my 3 kids up there at the top. And you can see that it is a long list of people because, like most people, I have probably 200 or 300 contacts in my phone. So you can see also these blue blocks that show the first letter of the last name. Those are the group headers in a long list selector. And because I'm putting this data in a long list selector, let's scroll back up here. And let's say that I want to quickly get to the Z's or something. I just tap one of these, then I'll tap Z. I'll tap Z. Maybe I don't have anyone that starts with Z. Okay, it had to think about it for a while. So let's try that again. That shouldn't have taken nearly as long as it did. Let's try it again. I'll go to C, then I'll tap M. See, it just needed to wake up a little bit. And that takes me directly to the M's. Now, let me take you into Visual Studio real quickly and show you the basics of what it took to get this to work. So I'm going to go back here and open up that project, which is called Long List Selector Demo. Scroll over. I actually ran out of USB ports on my laptop here, so I'm having to use a trackpad rather than a mouse, which is a bit of an interesting exercise in Visual Studio. But here we are, Long List Selector Demo. And I did a couple of things here that may be interesting to you. One is, here in mainpage.xaml, this is where I'm declaring a long list selector control. You can see that happening right here. Here with the group header template, I'm defining how I want those group headers rendered out, those blue blocks with a single letter in them, representing the first letter in a last name. And with the item template, I'm specifying how I want the items, the names of the contacts themselves rendered out. I'm using nothing more than a text block to do that to make it really simple. But I have set the is grouped property to true. We should be able to see that right over here. Or is grouping enabled? I have set that to true. And to specify what I want this jump list to look like when the user taps one of those group headers, I defined a style right up here at the top, which I decided to call long list selector jump list style. You can call it anything you want. I connected that to the control a little further below through a property name. And here's where I'm specifying how these things should be rendered out, how items should be rendered out, or the group header should be rendered out when we're zoomed out looking at the entire list. And one of the keys here is this grid cell size property. This is where I specify how big I want each of the items to be, each of the blocks to be, showing the first letters and the last names when the user is zoomed out to look at the jump list. So, again, none of this is rocket science. The documentation is not really good. It helps to have some examples to go by. One of the things you may want to look at if you go through this code is this right here, which is actually based on something that has already been published on MSDN. It's a helper class named Alpha Key Group that is basically a group class for any items that you want to group alphabetically. It goes in and looks at the content of the items, figures out what letters to populate the list with and things like that. I'm using this in this app, and that means that with this alpha group list, I'm not limited to contacts on the phone. Any data that I care to group alphabetically, I could marry with this alpha key group class and use a long list selector to make selections of items in that data set very easy. Okay, so what else do we get into if we look at new features? So another thing that you may find interesting is there are some new launchers. Now, launchers and choosers have been around since Windows Phone 7.0. Some new ones were added in 7.1, and even more are added in Windows Phone 8. I listed here the ones that have been added. There's a new Maps task, for example. If you wanted to build something like Bing Scout that uses the user's current location and shows nearby hotels, pizza parlors, or something like that, it takes a couple of lines of code to write that now. You create a Maps task object, tell the phone to launch it, and it launches a Maps task showing all of that. There's also a Maps Directions task if you wanted to provide a UI in your app, providing turn-by-turn directions from one address to another. Instead of writing all the code to do that, making calls out to Bing services to get the turn-by-turn directions, that's all built in. It's 3 or 4 lines of code now. And one of my favorite is the Share Media task, which I'm going to demo for you in just a moment. But here's how these things are used. Using them is no more difficult than using launchers and choosers in Windows Phone 7. If I wanted to use the user's current location and show coffee houses in the area, it's literally this 4 lines of code right here. I new up a Maps task object. Because I have not specified a value for the center property, it's going to automatically use the user's current location, and the search term specifies what I want this task to show me. If I instead wanted to show the user's hotels in the area, then I could just set search term to hotel, and when this Maps task map comes up, then the users would see pushpins representing hotels instead. Turn-by-turn directions, never been easier than this with the new Maps Direction task. In this example here, I'm newing up a Maps Direction task. I'm passing in the latitude and longitude of the Space Needle in Seattle, and then I'm asking for turn-by-turn directions from my current location to that location. Now, if I wanted, I could specify a starting location using a latitude and a longitude as well. I'm not forced to use the user's current location. I would just use the class's start property instead. But let me show you Share Media task. In fact, we're going to try something here. We'll see if it works. I hope it does. And if so, it should be kind of interesting. So let's go back out here. Actually, I don't need to go to Visual Studio yet because it is on my phone already. So we'll go back over to the phone. And I'm going to run something called Share Media Task Demo. Let's get out of that app. We don't need it anymore. Scroll down to the S's. We'll launch it. And what it lets me do is it lets me share a photo to my favorite social networking services. I can tap one button and select a photo that's already on my phone, or I can tap the button labeled Shoot and Share. Maybe I should have said take photo and share so you don't think I'm going to shoot you or something like that. But I'm going to shoot a photo of you, and we're going to upload it to Facebook, okay? So let me first pick this up and tap Shoot and Share. Now, everyone smile. Okay, let's see here. Of course, no one's going to be able to see you because of the glare. I'll accept the photo, and I want you to see what happens next. What I've done is launched a Share Media task. And I've taken this photo that we just snapped. And the Share Media task displays this UI right here. Does this look familiar? When you use, like if you go to camera roll on a Windows Phone 8 device, select a picture you've taken of the kids or something and want to upload it to Facebook, you can tap the little ellipsis to bring up the commands associated with the photo, and you can choose how to share it. So I'm going to choose to share it out to Facebook. Phone should already have my credentials. I won't put a caption in, but what I will do is tap this, and it says sharing to Facebook, just like the built-in UI. And if we go out to Facebook right now, I'm assuming that we're going to see that photo. Let's see. And look at that. How about that? Now imagine how much harder that would have been in the old days with Windows Phone 7. Now, in case any of you are uncomfortable with having your face posted on Facebook, I'll go ahead and delete that. Facebook friends who might have noticed it are wondering what in the heck was Jeff doing, I'll explain that to them later. But that is the Share Media task. Like the launchers and choosers, other task-based classes in Windows Phone 7, just simply make it easier for you to get into the built-in apps in the phone, into its built-in features. So do you like that feature? Pretty cool stuff, huh? All right, let's go back here. And let's get back to PowerPoint and see what else we can find to play with. Because there are just all kinds of good... It's like Christmas morning, and every time you take a present out from under the tree, 2 new presents appear. That's what Windows Phone 8 is like. For every feature you talk about, there are 2 more that are just waiting to be talked about, like the new maps and mapping APIs. I did mention there's a new map control, courtesy of Nokia. I mentioned also that the Bing Maps control is still there, but it's really only there for backwards compatibility reasons. But along with the new Maps control, there's some new mapping APIs, specifically a bunch of them in a new namespace that's part of the new .NET runtime, .NET for Windows Phone, not part of WinRT. The namespace is Microsoft.phone.maps.services. What does it have? It gives us classes for doing geocoding, reverse geocoding, and for doing route mapping. So if you did want to provide turn-by-turn directions or something in an app, and you didn't want to use the phone's built-in display for that, instead of making separate calls out to Bing services and getting those turn-by-turn directions, you can now get them from classes in this namespace. They've tried to make it incredibly easy to build location-aware apps, to provide turn-by-turn directions, to provide searchability for different features of an area like hotels, restaurants, and things like that. Some really, really cool APIs here. Here is one example of these new APIs at work, specifically the new geocoding API. Notice I'm newing up a geocode query object, obviously new in Windows Phone 8. What I wanted to do is attempt to turn an address, in this case one Microsoft Way. Whose address is that? Oh yes, that's Microsoft's address back in Redmond, Washington. And to turn that into a latitude and a longitude. This actually works. You can type it in, you can try it, and you'll see that it's generally quite successful. Not always 100% successful at every address you can pass in, but certainly since it's a Windows Phone, it better know what one Microsoft Way is, right? Now, in addition to doing geocoding, yeah. Well, yeah, it's a good question. Is there a need to specify a country? So in the U.S., we assume that there's only one country in the world, and that is the U.S. So this works, which tells me that in the absence of a country, they're probably assuming it's the U.S. Although, I don't know this for a fact. If I were designing this API, what I would do is use the localization settings on the phone. In the absence of a country, I would use whatever country's settings that phone has been set for. I can't tell you that's what they're doing, but I suspect that that's what they're doing. Now, you can also do reverse geocoding, which is kind of interesting. You can take a latitude and a longitude, and you can ask the phone to tell you what lies at that address or what lies at that location, what the address is. I've actually been pleasantly surprised at how well this works, how robust it is. And we're actually going to give it a try. Now, I don't know for sure if this is going to work here, but we're going to find out just how robust it really is. I'm going to go back to my phone here, and I'm going to run a little app that uses first the location service to figure out where we are on the face of the planet. Then it attempts to reverse geocode that to tell us what address I'm standing at right now. Now, I honestly don't know what the address of this place is, but if it's not in Antwerp, then we know that something has gone horribly wrong. But let's try this here. So let's scroll down and see if I can remember what I called this demo. Maps Services demo. That's it right there. So it's calling out using the location API, no doubt using Wi-Fi positioning to find out where I am since we can't get a GPS lock right now. And in the reverse geocoding, it's interesting, it wasn't able to turn our latitude and longitude into a street address, but it did at least figure out that we're in Antwerp. Now, Flanders, I assume, is kind of like a state in the U.S. Okay, so is that accurate? Antwerp is in Flanders? So it wasn't able to give us an exact address, but it was able to tell us that we seem to be in Antwerp, Belgium right now. Again, it's not that I couldn't have done this on Windows Phone 7. I would have had to rely on an external web service to do it, like a Bing service. Now, all of that is just built right into the phone. So when it comes to building location-aware and location-smart apps, the platform has gotten a whole lot richer than it was before. So let's see. Let's go back over to PowerPoint and see what Santa has under the tree for us next. How about new stuff in networking? Arguably the most important new features of Windows Phone 8. So, by the way, did we start? We have until 5:30. Is that correct? We started at 4:15. Good. Pace is actually pretty good. I should be able to get through all of this. When it comes to networking, they've given us all sorts of new stuff. One of the things that pleased me most was to see that they added Bluetooth support. Now, Do any of you know what a Parrot AR drone is? Does that name ring a bell at all? You can buy them here because I have friends in Europe who have them. I have a lot of friends in the U.S. who have them. I have a hobby that I put quite a lot of time into, which is building and flying large radio control aircraft. Parrot AR drone is a little device. It costs about $300. I believe it's a quadcopter. It has 4 helicopter blades, and you can fly it from your iPhone or your iPad. And it's really incredible. It actually uses a camera looking down. You can set your iPhone down, and the Parrot AR drone will just lock in place. It will hover right there, and it's actually using that camera sensor looking at the ground to try to hold its altitude steady. It does some amazing stuff. I love them, but guess what? I've never bought one. You know why? Because it was impossible for a Windows Phone to drive one of those things, because the connection between an iOS device and a Parrot AR drone is Bluetooth. And prior to Windows Phone 8, you could not possibly write the app that would drive that little quadcopter because you didn't have a Bluetooth API. Well, guess what? You finally have a Bluetooth API now. In fact, in tomorrow's NFC session, I'm going to show some really neat NFC demos. I'm also going to show how to use NFC to tap 2 devices together, establish a Bluetooth connection between the two so that you can pull the devices apart and the devices can still talk to each other over a socket connection. But Bluetooth itself does not require NFC. And that's just one of the big pieces of news that's new in terms of networking in Windows 8, Windows Phone 8. Another is NFC, near-field communication, which I'll say more about in a moment and say a lot more about in tomorrow's session. By the way, they brought over the Windows Networking Sockets namespace from Windows 8's WinRT. I was disappointed to find out that they did not include the WebSocket classes. If you're familiar with WebSockets, they came from the HTML5 world. They allow browsers and web servers to set up a 2-way duplex TCP channel so that they can communicate back and forth in real time or near real time. And WebSockets have actually outgrown HTML5 now. There's great WebSocket support, for example, in Windows 8. They did not choose to bring that over to Windows Phone 8. It doesn't mean you can't do some of that stuff. It means it's not quite as easy to do it. But let's talk about Bluetooth just a little bit, since I think this is something that a lot of Windows Phone 8 developers are going to be interested in doing. You probably know what Bluetooth is. You probably use Bluetooth all the time on your wireless headset for your cell phone or something like that. Bluetooth is a communications protocol. It can be used to talk to Parrot AR drones or almost anything else. And there are 2 big use cases for Windows Phone 8. One is for using Bluetooth to do app-to-device communication. That's where you've paired your phone with the device, like the speakers in your car or your Parrot AR drone flying machine, so that you can then pull up an app on the phone that knows about that paired device and then sends data to the paired device or even gets data back. There's another use case which is kind of interesting as well, and that is one that allows 2 Windows phones or a Windows phone and, say, a Windows 8 device to talk to each other directly using peer-to-peer communications over Bluetooth. So if I wanted to build a game app for the phone, for example, that allowed collaborative play, instead of forcing data to go through the cloud up to a web server and come back down to the other phone, as long as you and I are sitting in the room together so that our phones can see each other and communicate over a Bluetooth connection, I could do true peer-to-peer communications that way. Now, here's what the Bluetooth API looks like, just the basics of it. First off, there's an API on your phone for enumerating all of the devices that the phone has been paired with. If I had paired it to an AR Parrot drone, then when I walk this list, I would see that drone among the list of devices. The way you find out if Bluetooth is disabled on the phone, it can be disabled by the user, is kind of ugly. Basically, when you try to enumerate these paired devices, you get an exception thrown, and you look for a specific H result, which is the one I've listed right here. If that happens, you might want to inform the user, hey, before this app can work, you're going to have to enable Bluetooth in the settings on your phone. So one of the things Microsoft has done for us is given us an easy way to bring up the Bluetooth settings page in the phone so that the user can easily turn that feature on if that's what they want to do. Once you have found a paired device by doing that enumeration, establishing a Bluetooth connection to one of them is as simple as doing this. I don't know how it could be much easier. You knew up a stream socket object representing a socket connection between the two, and then you call connect async, passing in information about that paired device that you got from the enumeration. If that device is Bluetooth enabled, and it must be since it has already been paired with your phone, then you can now use that socket to talk back and forth with that device. Now, I'm not going to do a Bluetooth demo, but I do want to do a short demo on NFC. And again, I'm doing a full session on this tomorrow. I'll be saying, obviously, a lot more about it, going into more detail. But I do want to do one demo for you because I think, and I could be wrong. I'm wrong all the time. You can ask my wife if you don't believe that. I believe that NFC is going to be huge. I believe it is the future of networking. I think that now that we have it on Windows Phone, and a lot of Android devices have it as well, and as developers discover it and learn about it and learn about the cool things you can do with it, I think you're going to see it used more and more. Did you notice when you walked into this room, you held your badge up to that little device outside? You know what they were doing, right? That was NFC. They were getting a record of the fact that you were sitting in the session via NFC. Windows phones, not all Windows phones have NFC chips in them, but many of them do. If you have an HTC 8X, for example, or a Lumia 920 like mine, then it has an NFC chip in it, which is capable of both reading and writing NFC messages. Now, NFC, if you're not familiar with it, stands for Near Field Communication. It kind of came out of the RFID world, those radio tags that they put on items in warehouses so they can track the items as they go in and out. NFC is kind of a superset of RFID in a sense. It's a way that devices can communicate only when they're in close proximity to each other, generally 3 to 4 centimeters. So there are a couple of use cases. One is something like what you did when you came into this session. They have data encoded in a little NFC chip in your badge here. By the way, they told me earlier today that chip is rewritable. So after the conference is over, if you want to do some experimenting, creating NFC tags of your own, you can use your badge from this conference, so don't throw it away. In fact, I often throw my badges away after conferences. If any of you are going to throw yours away, give it to me, okay? Because I can use some blank NFC tags. It's not blank, but it is writable. So that's one use case where while two devices are in close proximity, they exchange messages with each other. The other use case is that you tap two devices together so that they become aware of each other through NFC, and then they establish a Bluetooth or Wi-Fi direct connection with each other so that now the devices can be pulled away and they can continue to communicate with each other even though they're no longer within proximity of each other. So I'm going to show lots of examples of both of those tomorrow, but let me show you just a bit about what the API looks like and show you one quick demo using my Lumia 920. Number one, there are two classes that play a large role in the new NFC API in Windows Phone 8. And this is, by the way, this is part of WinRT that they ported from Windows 8 and brought over to Windows Phone. It's kind of neat because in my demos tomorrow, my second NFC device is going to be a Build tablet, the Samsung tablet they gave out at the Build conference a couple of years ago. And it's running Windows 8. But the code that I wrote for the phone and for that tablet was almost identical because it's just WinRT. But one of the classes that plays a large role in the NFC API is one named Proximity Device that literally represents a device that is NFC capable, that is, has an NFC chip in it. If I can find out quite easily whether the device that's running my code is NFC capable by calling proximity device.getDefault and then making sure I get back a non-null return value. If that returns null, then I can't do NFC on this device because there's no NFC capability. If it's not null, however, then I can register for a pair of events named device arrived and device departed. And now, when another NFC device approaches mine and gets within proximity, within that 3 to 4 meter range, I will see that device arrived event fire. And if I want, I can now talk to that other device. Also, when that device is pulled away, I will see a device departed event fire. You could elect, for example, when you detect that another device has arrived within your proximity, to send it a message to see how it would react. Or you could elect not to send a message. There are lots and lots of ways of going about this. The demo I'm going to show you shows just one use case for NFC. What I've done is I've taken a Samsung Tactile. It's a little writable NFC tag that you can order from Amazon or from a number of suppliers. And I've written a very special NFC command to it that is capable of launching a Windows Phone app or a Windows 8 app and passing parameters into it. Now, to write that launch tag out, I use my phone as an NFC writer. Your phone can not only read NFC tags and read data from other NFC devices, it can write to them as well. This is the code that I used to write the NFC tag that I'm about to pull out of my travel case and use. Now, the launch tag, this so-called launch tag that I'm writing out here, is only capable of launching another Windows Phone 8 app, but it is possible to change this code a bit and write out what we call a dual launch tag, one that will launch a Windows 8 app or a Windows Phone 8 app. With a little help from an open source library, you can also write out launch tags that will launch apps on Android phones. Presumably, we may be able to one day launch on iPhones if Apple ever decides to support NFC. By the way, if anyone ever asks you, what can a Windows Phone do that an iPhone can't? Your answer, NFC. Get with the program, Apple. There was a lot of rumors before iPhone 5 that it would include NFC support. It does not. So for now, it's Windows Phone, it's Android, it's BlackBerry, it's a few others. But Apple hasn't yet thrown their hat in the ring. Don't you love it? One of the things you need to know, if you're going to write launch tags to NFC tags to use them to launch apps on devices and pass parameters into them, is how in a Windows Phone app do you recognize that you were launched from an NFC tag and consume the launch parameters that were written to the tag. This is the code for doing that. It's 100% seamless on Windows 8. It's 99.9% seamless on Windows Phone. You've probably built phone apps before where you've used navigation context.queryString to consume data passed to a page inside of a navigation event. Well, when your app is launched from an NFC tag, Windows Phone 8 passes you a special query string parameter that you access like any other query string parameter through navigation context.queryString. They give that query string parameter sort of an odd name, ms underscore nfp underscore launch args, but now that you know that name, you can not only detect that you were launched from an NFC tag, but you can tell precisely what value, what launch arguments were encoded on that tag. So with that, we're going to give it a try. Now this is one of those demos where I hope it works. Sometimes it just fails. I want everyone to cross their fingers, okay? What I'm going to do is first reach into my bag and pull out these tags that I carry around with me for demos. In fact, just for good measure, I always carry with me a packet of Samsung Tactiles. It's a great way to learn about NFC and to play with NFC. Carry several blank tags with me in case something goes wrong, and I carry several that are pre-written. Now, you can't see this very well, but it's just an ordinary business card. On the back of it, I've put a sticky back Samsung Tactile. It measures about 2 centimeters by 2 centimeters. There's actually a tiny chip inside it, a passive NFC chip, to which I can write data. Write operations, you're supposed to be able to write to this one 100,000 times. One of the things that I find interesting about NFC is there's a chip in here that's going to send data out when another device like a phone gets close to it. But how is that chip powered? It's powered inductively. It's one of the reasons that NFC requires that 3 to 4 centimeter proximity. If any of you have a Lumia 920, you may have a wireless charger for it as well. Same thing right here. Basically, when the phone gets close to it, electromagnetic waves power the chip on here so we can emit data. Isn't that cool? Now let's try this out. I want to go back to the screen here where you can see my phone. And I'm going to hold this tag up to my phone and see if I can launch an app from it. Okay, go back to the start screen, although that's not totally necessary. And I'm going to lift this up so I can slide the card underneath it. And you may hear a little ding ding, which is my phone telling me that it's detected another NFC device. Okay, look at that. It says, someone wants to use phone weather demo with you. I'll tap Open App, and it launches a Windows Phone app I wrote that takes the US zip code you plug in and shows you what city and state correspond to that and what the current temperature is at that location in degrees Fahrenheit. That's actually where I live. It's a little town outside of Knoxville, Tennessee, near the Great Smoky Mountains National Park. It's supposed to be spring back there right now, but 32 is pretty cold. That's 0 degrees C, folks. It's pretty cold. It's a good thing I'm right here. It's a lot warmer in Belgium. So what happened here is this. I used code very similar to what you saw on the slide to write a launch tag. Wrote a command to this little NFC tag that tells a Windows Phone app to launch and passes it a parameter, in this case, a zip code. I didn't have to do anything else special. When I held this thing up to the NFC chip in the back of my phone, it was the Windows Phone operating system that saw that another proximate device had entered that 3 to 4 centimeter range, that read what was encoded on this, recognized it as a command to launch a Windows Phone app, and that launched the app. It also took those parameters, the zip code that I had encoded in this launch tag in here, and passed it in the query string so that in my code I could just read it and consume it like any other query string. In other words, that app, which I had written long before I even thought about writing NFC enabling it, I only had to change one line of code to make it respond properly when launched from an NFC tag. And that line of code was to have it recognize that special query string parameter that's added in. So pretty cool stuff, and that's just a small sample of the kinds of things I'll be showing tomorrow if NFC interests you for a phone and for Windows 8 devices as well. So that is NFC. Now, let me, just so that I don't forget, I would set these under my phone, but if I do, all kinds of weird things are going to happen because I have a bunch of tags in there. NFC, I think, as I said before, it's one of those things that once developers learn about it, they're going to think of all sorts of creative uses for it. What about this? One of my favorite new features of Windows Phone 8 is voice and speech support. They built in some new APIs into the Windows Phone runtime. This is among the new APIs that they added when they ported portions of the Windows runtime over from Windows 8. They added to it, among other things, APIs for doing speech recognition, that is for converting voice to text, for speech synthesis, that is converting text to voice, and for doing something that they call voice commanding. Now, here's what Microsoft means when they talk about voice commanding on a Windows Phone. You can already launch an app by saying, "Open Angry Birds," or something like that. You can still do that, but you can actually now voice command enable your app so that if the user speaks parameters as they launch it, "Open Angry Birds" and go to level 6, your app can interpret that and can go straight to level 6. So let me show you a few basics of what these APIs look like, and then we're going to try it, see if it actually works on my Windows Phone here. So in terms of converting text to speech, there is in the Windows Phone runtime for Windows 8 a new class named Speech Synthesizer. It's a very easy class to use. It is awaitable. That's one of the nice things here. If you're familiar with async and await from Windows 8 and WinRT, while they don't provide a lot of support for that in the new .NET APIs for Windows Phone 8, everything they brought over from the Windows Phone runtime and that they added to the Windows Phone runtime that is asynchronous supports the async await pattern, which is why I call await synthesizer.speakTextAsync, and it voices that text for me. It's kind of interesting, too, They have over 30 different installed voices built into ROM in the phone. So if I want that spoken with a German accent or a French accent or something, it's just a matter of picking the right installed voice. Now, the installed voice number 1 is one that speaks with a German accent. And if you want, you can type this text into an app, run it on your Windows 8 phone, and you'll see exactly what I mean. There's also support for converting speech to text. I don't know about you, but with 3 kids at home, kids don't call each other anymore. They text each other. Have you noticed that? And they don't call mom and dad either. They text mom and dad. So it seems like every time I'm in the car driving down the road, bing, bing, I get a text message from my son. Well, I don't want to text while driving. That's illegal in most U.S. states and is pretty dangerous anyway. But now, because of the great voice support in Windows Phone 8, I can respond to that text message by voice and have my Windows Phone send that text message to my son. You can build the same kind of capabilities into your own apps. Let's say you're building a notepad type app for Windows Phone. You could put a button down in the taskbar that a user presses to enter by voice. What you do when the user presses the button is new up a speech recognizer UI like I'm doing here, called Recognize with UI Async. Windows Phone will then pop up that recognition UI that I show in the screenshot at the bottom, and it will give you the text that it thinks the user spoke. If you've played with this on a Windows Phone, it's actually quite good, in some respects better than Siri. In fact, my wife uses an iPhone. She's been complaining lately that my Windows 8 phone seems to work better with voice recognition than Siri on her iPhone does. It is also possible, even though this isn't documented quite as well, to interpret voice commands without popping up a UI. You can do what I'm doing here. You new up a speech recognizer object and you give it a grammar. Here I'm adding to it a custom grammar list with all the words that I want to be notified of if the user speaks. And then I call await recognizer.recognize async. When that returns, then whichever one of those words the user spoke, if they spoke one of them, will be handed to me through result.txt. In terms of voice commands, that is, allowing your app not only to be launched by voice, but passing voice parameters in as well, it begins with something called a VCD, a voice command definition file. Now, I don't have time to go through all the grammar here, but basically, you're defining here in a simple XML file all the different commands that your application supports. Then, over in app.xaml.cs, when the app starts up, you call this new static method in the new voice command service class, the method being install command sets from file async, and pass it that VCD file that you saw in the previous slide or one like it. And now an interesting thing happens. When your app is launched, you are given information in query strings telling you what commands the user spoke, translating or mapping back to the different commands that you specify that you recognize in that VCD file. Now, I just want to go straight to the demo since we're almost out of time here and show you this at work. So once more, let's pop out to this UI right here. And I'm going to run a little demo here, which is kind of fun. In fact, I'm going to attempt to launch it by voice too, so this should work even if I had done nothing special. Open voice demo. So it's starting my app. Now, again, it doesn't take anything special to do that. Any Windows Phone 8 app can be opened that way, but notice by default it's showing a red rectangle. I've built a VCD file that specifies different parameters that a user can follow that command to open the app with. So let's do this. Let's shut the thing down and let's try it again. Voice command, show yellow. Whoops, I've got to tell it to start listening. Voice command. Actually, I called it voice demo, so let's go back and do this. One more time. Voice demo, show yellow. And look at that. So I took that color parameter, which I defined in a VCD file. It was passed to me in a query string, and I set the color, but watch this. Red. Blue. Green. Shake. Now, you probably can't hear it, but it actually talks back to you when you do that. Download this app and try it on your phone. It says things like, ooh, that feels good. Would you please do it again? And let's try it one more time. Shake. That time she said, was that as good for you as it was for me? So you may want to be careful where you do this at. But what I'm doing here is I'm using a VCD file to allow the app to accept color parameters on startup, so I can automatically set the square to that color. And then once the app is started, I'm using that speech recognizer class to allow it to accept additional commands, changing the color of the rectangle, telling it to shake, and things like that. And then, in order to have her speak back to me, I'm using the first class I showed you. I don't recall the speech synthesizer class to actually synthesize some text. Very simple. It's a fun app to play with, kind of shows the different things that you can do with voice commanding and things like that. Now, we are out of time, but let me just briefly walk you through the things that we didn't talk about. If you look at these slides here, there was just one major topic I think that we had not covered. No, there were a couple. Let me just skip right on to this last one right here. One of the cool new things that you can do, and I'll give you a URL so you can download the source code and see it for yourself. Your app can now integrate with the lock screen on a Windows phone. This is something they brought over from Windows 8. What you can do now is have an app that registers a background task. The background tasking API, by the way, did not change going from Windows Phone 7 to Windows Phone 8. In that background task, which nominally executes every 30 minutes or so, you can update content on the lock screen, text on the lock screen, and a badge, a number 1 to 99 on the lock screen. It does require that the user go into the phone settings and add you to the list of lock screen apps, and you cannot force your way onto the lock screen. A user has to do it. But the sample that I built into here is one that wakes up every 30 minutes or so, even when it's not running. It uses a background task, uses the location API to find out where on the planet I am, and then it calls out to a web service to find what the current weather conditions are at that location. Then on the lock screen and on its tile, which is a flip tile, it shows the current temperature in degrees Fahrenheit. And I actually use this thing because I travel a lot, and rather than get to a new city and have to go into the Weather Channel app or something, tell it to find out where I'm at, show me the conditions, it automatically, as I move around the planet, it just automatically shows what the current temperature is wherever I'm at. And it's a good example of how to integrate with the lock screen. Last thing here, let me give you a URL from which you can download these demos if that's something you're interested in. I'll go over to my SkyDrive and grab that URL of the zip file, and you can write this down if you want to play with these samples yourself. So let me grab a sharing link here, and I'll ask it to shorten it. And the final thing I'll do is make this bigger, so let's put it over in Notepad. And if you want those samples, you can get them from this URL right here. Realize that SkyDrive URLs are case sensitive, so you'll need to get the case right as well. But inside the zip file at that URL are the demos I just showed you and some that I didn't, all designed to show what's new in Windows Phone 8 for Windows Phone 7 developers. So, any last questions? Because I'll need to get out of the way for the next presenter. Tell you what, we'll end the session. I'll tear down. If you have any questions, I'll meet you outside, and we'll talk about Windows Phone 8 all day if you want to. Thanks for coming.